Okay, so good morning, good afternoon, good evening, I should say, depending where in the world our attendees are joining us from today. Thank you so much for taking time out of your schedule to join us for the World Technology Universities Network webinar. We're joined this morning by Professor Michael Affenzeller, who will be our speaker and be delivering today's lecture, and also Professor Peter Scharf, who is the chair of the World Technology Universities Network, and he will be doing a brief introduction before we start our session. Just a little bit from me. My name is Denise. I'm the Development Manager at the World Technology Universities Network. I'll be here in the background, monitoring the chat and passing on any information towards the end of the presentation to Professor Affenzeller. Just a little housekeeping. If we could just ask attendees to remain muted throughout Professor Affenzeller's presentation. It's up to you whether you have your cameras on or off, and there will be time at the end to ask questions, but I'd encourage you to ask any questions that you have in the chat box. I'll be monitoring that and I can relay them to Michael towards the end of today's session. Before we start our lecture, we're going to hand you over to our chair of the WTUN, Professor Peter Scharf, who's going to give a brief introduction. So over to you, Peter.
Thank you, Denise. Hello, everyone. I'm very grateful to Michael to contribute to the scientific program of WTUN by giving this webinar. Michael, thank you very much. I think it is absolutely great. And the topic is also absolutely great and a very, very good topic because it is influencing, I think, our whole society, not only the scientific branch, but the whole society in the world, and it's so important. As you know, the title is Prescriptive Analytics and Industrial AI, and the subtitle, Only Those Who Know the Past and Understand the Present Can Shape the Future. Yes, I can only say, yes, that's true. Yeah, we have to look backwards and have to accept, or let's say discuss, what is going on just now for being able to shape the future. We are in a very, very interesting period of time, because there are many developments, current developments now, which are so important and so interesting, and as concerns me, also surprising. That we have to discuss this in a wider selection of members of the scientific community. I should address the so-called ChatGPT. I think everyone has already heard about it. Yeah, it's let's say a shortened form. The whole is a chatbot generative pre-trained transformer. And this is an open source program given by Google Brain, and it enables people to write things about a certain topic. You can tell to the program before, and you will receive a more or less perfect speech, or let's say, article, whatever. Yeah, and it's astonishing how perfect is the grammar, and how perfect are the words, and also how perfect is, to a certain extent at least, the content. Yeah, and I think we are facing these new possibilities, and we have to take into consideration in future how to deal with these artificial intelligence programs. For example, pupils or students, could betray by just using such program if they are, let's say, required to write an article or to write a certain work on something. Yeah, maybe a whole publication or a dissertation could be based on such things. I think in the experimental sciences it's not so easy, but in the social sciences, for example, it could be very important and possible to do this. Yeah, so we have to rethink about our our efforts to avoid plagiat or something like that, or using such programs. I think Michael will maybe also touch a bit, at least, yeah, these new possibilities. But as far as I understood, it will mainly have to do with artificial intelligence in industrial applications. Yeah, is it correct? Okay. So I do not want to make too much words. Thank you for being here, everyone. And I'm very glad that WTUN can contribute to such a very important development. Okay. Denise, could you please introduce Michael now?
Absolutely, it'll be my pleasure, and thank you for that introduction. So I will shortly hand you over to our speaker for today, and then we'll take a bit of a backseat and listen along with all of you. I just wanted to tell you a little bit about our speaker today. So Professor Dr. Michael Affenzeller is the Professor for Heuristic Optimization and Machine Learning at the University of Applied Sciences, Upper Austria, graduating in mathematical computer science, and did his doctorate and habilitation in computer science with a special focus on applied systems science. Concerning university administration, Dr. Affenzeller has served as Vice Dean for R&D at Hagenberg campus and as the scientific head of the Software Park Hagenberg between 2014 and 2022. Since July 2022, he has served as the Provost at the University of Applied Sciences, Upper Austria, and he has published over 300 peer-reviewed papers in journals and collective volumes, bringing together machine learning, simulation-based optimization, and meta-heuristics with a special focus on adaptive search in dynamic environments. In the context of prescriptive analytics is Michael Affenzeller's research focus for the next years, and what brings us here today to hear from him. So without further ado, I'd like to hand you over to Professor Michael Affenzeller for today's session. Thank you, Michael.
Thank you very much, Denise. Thank you, Peter, for your really kind introduction. I'm very much looking forward to meeting you all again in person in Ilmenau later this year already. Now let's try to share the screen. So I guess this should work. Can you see the title page in full mode?
Yeah, all good here.
Okay, perfectly fine. So thanks again for the kind introduction, and next couple of around 40 minutes, I guess. So I will give a talk about prescriptive analytics and industrial AI. The talk is mainly in three parts. First of all, I will take the opportunity to say a couple of words and also some personal impression about the field of artificial intelligence and the subfields which are more related to technical applications. And then I'm getting closer to the title of prescriptive analytics, which is also seen as the fourth stage in the analytics cycle. And finally, I will go a little bit more into detail about what we are doing at our university, and especially at the Hagenberg campus of our university in this topic. First of all, let me tell you a couple of words about our university, which is in the northern part of Austria, in the heart of Europe. One could say between 1 or 2 hours by train or by car to Vienna, Salzburg, Munich, and even Prague is not far away. And our university is dislocated among 4 campuses, which are each of which is specialized to a certain topic. But especially in the field of prescriptive analytics, it's digitalization in industrial application. It's also a topic of cooperation, even within our university and with other university partners. In Hagenberg, which is the computer science campus of our university, we have the special situation that the university campus is embedded in a so-called software park Hagenberg, which is a special kind of technology park. You could say what makes it different to a normal technology park is that it's all around IT and software at this place, from basic research to education towards companies who are taking care of making the prototype a product, and they can even take care for maintenance. So that's more or less the environment where we are working in. Now I will step over to the field of artificial intelligence, which is very popular again right now. It has been popular also in the past, which you can also see with this very, what I would say, still valid quotes of famous researchers like John McCarthy in the mid-1950s. He was he's from Stanford University, responsible for the Lisp programming language, is one of the first artificial intelligence programming languages. And he stated artificial intelligence as the science and engineering of intelligent machine. This very generic statement could also hold, also holds nowadays, also for ChatGPT, as being mentioned from Peter before. A little bit more detailed is this statement of John Koser a little bit later, which I especially like, because John Koser, also from Stanford University, introduced the so-called A to I ratio, the artificial to intelligence ratio. In that time, which was also one of his favorite example, there was a milestone result in artificial intelligence by IBM's Deep Blue, reaching grandmaster level at chess for the very first time. And according to John Koser, the A to I ratio of Deep Blue was not very high, because it was openings of human intelligence which were stored in large databases. There were end games also developed by human chess masters, which were stored in large databases. And according to John Koser, the real intelligence of Deep Blue was only in the middle of the game, where the program couldn't rely on the openings and on the end game. So it's really about the difference what is pre-supplied by human intelligence, which is also a lot in case of ChatGPT, and what the intelligence which is evolved by the machine. Nowadays, computer programs also for chess, superior to human level already, or Go was such a more recent milestone results, can improve their skills by machines playing against machines, which would have a far higher A to I ratio according to John Koser's definitions. So AI has become very, very popular again. Even if the techniques which become applicable in recent years already exist for decades, partially, but now we have the amount of data and the computational power that the results really come into life. Nevertheless, I think from a scientific perspective, we have to take careful in order not to mismatch science and fiction too much, because there have already been times where the field of artificial intelligence has been hyped a lot and maybe even overhyped. And then if the expectations couldn't be met, the so-called AI winters were following such phases. And I think if we keep expectations realistic, it's the more serious way of approach. And if nowadays someone talks about artificial intelligence, we have to be aware of the fact that there's a bunch of many different algorithms, methods, which are standing behind there's even some kind of maybe philosophical discussion if there will ever be something like a general AI, or if it will be specialized AI systems rather, as we see it at the moment. I personally think that it will appear more and more as a general AI, even if under the cover it will be a smart interplay of specialized AI systems, and that's what we are also seeing now. There has been a lot of progress in the last couple of years in black box AI methods applied on unstructured data. For example, if we take a look about the fields of investigation which are on the focus in more recent years, we see already that it's more going again back into theory, into explainability, into interpretability, into human-centeredness. We want to understand why AI system is acting as it is in order to interpret the results, and that's also an enabler for bringing the human into the loop of AI systems and in interacting AI with artificial intelligence systems, and even to interpret the results delivered by artificial intelligence system. That's also what we can see by another listing of recent AI trends, and also which brings me closer to the field of analytics, that AI techniques should be acting as team players, incorporating with each other, like with machine learning interacting with simulation techniques and with optimization techniques. And also that's something I'm from a rather European perspective, Austrian is in the middle of Europe, but in the northern, in the southern part of Germany and in the northern part of Italy, we still have a lot of producing industry, even in the automotive sector. And I think from the many subfields of artificial intelligence, every region should be careful about picking up those topics which are really relevant for certain kinds of applications. And I do think that it's not the best strategy just to follow global trends, which are nowadays mainly set by the United States and China also in the meanwhile, which is more about the needs of software companies or producers of cellular phones and mobile devices or so. And prescriptive analytics, from my point of view, is interacting with artificial intelligence, or takes advantage of artificial intelligence techniques, especially suited for industrial applications. Here on this slide, we can see according to the literature, the 4 stages of analytics as the field is seen nowadays, starting from the descriptive stage, where we have database, statistics, analytics, visualization, which is more about understanding the past, data from the past, which we would like to better understand, analyze, visualize, and so on. And based upon this, there comes the diagnostic and the predictive analytics stage, where already artificial intelligence techniques comes into play, mainly techniques from the field of machine learning. And again, based upon this, there is prescriptive analytics, which more or less couples those machine learning techniques and database prediction models with optimization and simulation in order to obtain prescriptions. Or it's also some kind of, one could even say, re-analogization because the findings from the digital world should be somehow brought back to the real world by prescriptive analytics. And of course, prescriptive analytics cannot stand as its own, because it relies on the pre-stages of the descriptive, diagnostic, and predictive stage, which all in all makes it a huge coupling of techniques, and also I think a need for team play, which is especially interesting for a university network like the WTUN, which is also intended to bring people together, to bring expertise together, to cooperate with each other, because you cannot go into depth for all of these topics in an appropriate way. And in one research group, you have to bring together the experts of the certain fields. Let me start with a very simple example, bringing the idea of what prescriptive analytics could deliver for industrial questions, something which we all know. If we have a car and buy tires from time to time, here in Austria, we even change tires between summer and winter, even by law. In wintertime, you have to have winter tires, and until I think April 15, if there are snowy conditions, then summer tires are allowed again. And if you want to buy new tires, maybe you read up some tests, what's about the characteristics under wet condition, under dry condition, under snowy conditions, what's the noise when under high speed, what's about fuel consumption, how long do they last. So there are many characteristics which should be optimized by the manufacturers. And being competitive from the perspective of manufacturers by having a good mixture of properties is critical for the success on the market, of course. And what prescriptive analytics can contribute in this way is that a manufacturer does not rely that much on testing as it has been done in previous years, to have a lot of expert knowledge, of course, a lot of experience, and then doing some new mixtures of the materials and test it into the field. With prescriptive analytics techniques, you can collect data from previous tests of many different mixtures of materials and analysis of their resulting properties, learn machine learning models out of this, and then optimize towards the target variables in a way that you will have an optimized combination in the sense of multi-objective optimization, which means that at the same time you do not only want to optimize one single target, but you want at the same time optimize a couple of targets, and the resulting mixture, which you have been researching or which you have been finding using those machine learning, optimization, simulation techniques, then have to be tested again on the test bench again in order to validate or disvalidate what you have found out. So just to start with a very simple example, which we all, I think, have some relation on it if you have your own car. And this very basic principle is in different kinds of application. What we are doing a lot in the field of prescriptive analytics here is a cooperation with our university with other universities from the region and industrial companies here for the design of friction systems also for automotive applications, but also for trains or for wind power stations. They have this kind of friction systems which need to be optimized in order to meet certain requirements. And again, it's multi-objective optimization. They should have some certain properties. They should last a certain minimum amount of time, and that shouldn't be too costly. So that's more or less what's done. And before starting this prescriptive analytics project, the average error of prediction to what has been benchmarked then on the test bench was about 10%, and during the project we could decrease this error prognosis from 10% to 2%, which can save a lot of costs in production and still make sure that all the requirements are fulfilled as needed. A more technical example, but it's the very same principle as before with the car tires. Let me come to some topics which we are doing in my research group at the Hagenberg campus of our university, with some impressions also there. It's at the countryside, about 15 car minutes from Linz, northern towards the Czechoslovakian border, and we are dealing in the core with optimization, heuristic optimization, and machine learning. If you're interested or if you have some applications in this field, please feel free also to have a look at our software, the Heuristic Lab software, which is open source. So as a university development, we decided to make it open source. And from the core research interests, we are interested in designing new algorithms, analyzing the algorithms, and of course also applying those kind of algorithms. One field of applications is on the, what I would say, standard applications of meta-heuristic methods in operations research, like logistics optimization, production optimization, intralogistics optimization, and all of this stuff. And another field where we are doing quite a lot is in the machine learning sector, with a special focus on white box machine learning, opposed to a neural networks, for example, which is a black box machine learning systems with symbolic regression or symbolic classification, which are supervised learning techniques for regression and classification tasks. You can also evolve complex nonlinear models which are still interpretable, at least to a certain extent, as I will show later on. And a very interesting field also within the scope of prescriptive analytic is when it comes to simulation-based optimization, because in simulation-based optimization, which is typically applied when the formulation of a, say, combinatorial optimization model or so cannot achieve that degree of detail as you would like it with a simulation model or a digital twin, you can, depending on the effort you want to take, achieve almost any degree of detailedness when modeling a system. But on the other hand, runtime becomes a very critical issue. Heuristic optimization techniques, if they are powerful, often rely to have millions of solution evaluations in order to perform well. And if a solution evaluation takes the run of a simulation model, which might take from seconds maybe for a discrete event-based simulation, up to hours for very expensive simulations like fluid dynamics or such kind of simulation-based models, you can no longer use that many solution evaluations. And as some kind of compromise, you can use machine learning techniques in order to learn an approximate output of the expensive simulation in the offline stage. You produce many input-output couples of the expensive simulation in the offline stage where you have time, and then you try to learn an approximating function for the outputs, which is usually not that accurate than the exact simulation output, but often good enough for the early stages of optimization in order to decide whether or not the solution candidate is complete nonsense or could be interesting. And then step by step, you can again use more powerful optimization techniques by hybridizing the surrogate models learned by machine learning with the expensive simulation in order to improve simulation results again. Here, there are a couple of characteristics and details about our open source software environment. I will not go through the details, but we can, of course, give you the slides after the presentations, and then if you're interested or want to give it a try, you can have a look on the details. And for this, also the next slide is thought to see where you can download Heuristic Lab. Yeah, in the most recent version. Well, let's go back to the machine learning part by opposing black box approaches like typically done with deep neural networks in recent times, or white box models with the aim to deliver interpretable models which are important to better understand a system's behavior, or also to incorporate a human expert from the field or for the domain into the process. However, for many applications, black boxes are very powerful, especially when it comes to unstructured data like pictures, video data, audio data. Then there has been a lot of progress, but especially in the industrial field where we're working a lot with numerical sensor data, we very frequently have modeling questions based on structured data, and there also a lot of progress has been achieved far beyond linear modeling, as the next couple of slides will show. We are using here evolutionary approaches from the field of evolutionary computation, or even more concrete from genetic programming, where the idea is to use the natural evolution as a role model in order to have a population of solution candidates and optimize their properties, optimize their characteristics generation-wise by repeatedly applying selection, crossover, and mutation. The aim of crossover is to generate new offspring solution out of two above average parent solution candidates by mixing their characteristics, and iteration-wise lead to better and better solution candidates, which is an optimization task, of course, in the inner part, where similar to other machine learning algorithms, you want to minimize the error on your training data, as been showing here. I hope the video will work. So each line would represent a candidate function which aims to approximate a certain target function. And here on this toy problem example, we can see this evolutionary approach, how over the generations the error becomes smaller and smaller, and the fit of the curve becomes smoother and smoother towards the achieved towards the achieved target. Of course, just a very simple demo example with only a little variables involved, but I think it pretty nice shows the basic principles. And that's what usually our contribution of our research groups is in larger consortiums to take care about the interpretable models and also about the optimization tasks. Here, another example where you can easily imagine that formulas like this can be interpreted by a human expert from the certain domain, no matter if we are acting in the field of mechatronics, physics, chemistry, or metallurgy, just to give you some examples. Frankly speaking, the last formula was a little bit idealistic. In the background, you have to do also some post-processing to make it really interpretable. That's what's also supported by the software which we have been developing over the years. Again, some concrete examples of which are representative from my point of view for this kind of approach here from the automotive sector to design so-called virtual sensors. Virtual sensors means that it's not a physical sensor, but a machine learning model which can be used instead of a physical sensor. So for some sensors can only be measured under laboratory conditions, which in the automotive sector means test benches. And in the field, in your car, you cannot have many sensors because they have too much weight or are too expensive or only work under certain temperature conditions. There might be several reasons. But if you collect data from the test bench and use as input variables, those variables which you will also be able to use later on because they are easy and cheap to measure, and try to learn the outputs which you cannot measure in the field, then we name this a virtual sensor, which is a very common term in the field of mechatronics. And that's also a field which we have been working together for many years, together with BMW, for example, or also together with ABL, which is a large Austrian engineering company with a strong focus on the automotive industry for combustion as well as for electrical engines. Another example, even closer to prescriptive analytics because it incorporates optimization again, is also from a technical application. It's about plasma nitriding processes where you optimize the characteristics of metallurgic surfaces by plasma nitriding. And the idea is, and the company also has some, say, recipes which are kept very secret, and if they apply a certain recipe, the outcome is a triple or quadruple of quality values which you want to achieve: surface characteristics, hardness, and such properties. But it would be, of course, far nicer if you could wish a couple of properties and then automatically generate a recipe. And that's, again, then the prescriptive analytics approach, to have the modeling stage as the first stage, to model each desired output with a machine learning model, and then couple this with optimization in order to optimize the input parameters, which you can set in the process in a way to get as close as possible to your desired output. And then, of course, you have to test it again if what you have been calculating turns out to be right or not. I skip this one because we are getting short in time. It's an application from the steel industry, which we are also cooperating a lot and which brought us to some ideas by designing hybrid algorithms where you can use a priori knowledge and try and combine it with knowledge generated by data. That's what's being indicated here. If you have, for example, some basic formula structure, which you know from natural sciences, but want to learn some details data-based in this syntax tree representation, you can fix some structures and open some structures for learning with a subset of variables. For example, that's the idea which has been further developed here in this, together with the steel making industry. Finally, let me give you some impressions of a very recently started research project. We were fortunate to obtain funding for a project for at least 4 years, and if we're doing a good job, it will be renewed for another 4 years. Here, we want to have a hierarchical decomposition of a system. In the majority of cases, we're thinking about technical systems where each of the system components, if we start bottom up, can be a simulation model, maybe expensive, maybe if too expensive, can be replaced by a surrogate approximator function of the expensive simulation, or can be done directly by a data-based model if you have a sufficient number of data which allow you to describe a part of the system. And then you can encapsulate a part, and again, on a higher level, have the opportunity to model this part, for example, with a surrogate model by machine learning, and therefore have this compromise between accuracy and performance of your modeling approach, which is especially important. Let me go to this slide directly, which is especially important for optimization. Again, if you have this hierarchical decomposition of an overall system, with many degrees of freedom about to choose between data-based, simulation-based models or surrogate-assisted models, and then using an orchestrator to take the appropriate compromise between accuracy and performance of your modeling task, which is needed for your optimization at hand. That's what we have been starting to do in the year 22, and it's going on, working on the framework allowing this. Well, and what's next? Good question. I don't know exactly myself, but I think it could go into a more cognitive direction if we observe the trends of interpretability and explainability in those fields of AI, and also by incorporating the human user more integrative into the overall system. I think this could be a very, very interesting and promising direction to go, which already leads me to the end of my talk. Thank you very much for listening.
Thank you very much, Professor Affenzeller. That was a fascinating talk, and I'm sure that we have some questions for you from our audience. I just wanted to thank you on behalf of the WTUN for bringing your time and also your expertise to the session today. We have a question that's been submitted via chat, so if I just move straight onto that, perhaps it will encourage others to either raise their hands or submit their questions. Sahel Razak starts by thanking you for providing context and the applications of prescriptive analytics and its relation to optimization methods. And they ask, have you come across any applications of prescriptive analytics in the fields of smart power grid and IoT? I believe that's the Internet of Things, please.
Smart power grid, yes, is a topic of definitely increasing importance, together with the trend of using renewable energies like solar power or wind power. We have a lot of disturbances in our systems, because we cannot really say when we have sunny conditions or when we have windy conditions, which is very interesting to use simulation models, and also using simulation models for scenario optimization. So under which circumstances a power grid system is stable enough in order not to suffer from a blackout or something like this. We had a small but still smart project where a school has been especially equipped with a water power station, with solar energy, and also with wind power in a very small environment, learning control systems out of it, how to and when to use battery storage in order to optimize robustness, in order to optimize also the costs, of course, under certain conditions. And here is a good example for this hierarchical decomposition. Actually, we even want to have a use case in the prescriptive analytics project in this power grid systems, because when you have many such users, they can be encapsulated again. All of them have their own stochasticity, and then analysis of robustness can be taken more seriously, as already done in practice. Even sometimes, if you have some combinations of users borrowing their storage capacity and such kind of scenarios, or even which capacities of battery do I need, or is for a more strategic level for political decision makers, or is there an opportunity to pump up water to a hill for intermediate storage, which Austria is quite privileged in to use this kind of intermediate storage, and such questions is a very good application ground for combining simulation with optimization and machine learning again.
Thank you. Great. Hopefully that answered your question, Sahel. We have another question that's been submitted in the chat that I may put to you first, and then I can see that Professor Scharf also has his hand up. So we'll come to you in a second, Professor Scharf, but I'll just ask the question from the chat. So Yoba Artega asks, Professor Michael, in your opinion, what are the current challenges that BDA and AI should overcome in order to accelerate their adoption by industry?
Well, what we very frequently face in practice is about data quality. So especially in small and medium enterprises, maybe in the large industry companies, data quality is often quite okay, but a very limiting factor in many potential application is about data quality. And already with what we have now in terms of machine learning techniques and optimization potential, a lot more could be achieved, assuming good data quality. And again, as already mentioned during my talk, we shouldn't raise our expectations too high, and it's still stochastic methods and optimization which appear to be intelligent, but well, it's, at least from my point of view, they only appear to be intelligent.
Thank you. Professor Scharf, I can hand over to you. Oh, you're just on, you're on mute, Professor Scharf.
Excuse me. Michael, do you think that artificial intelligence is or will be able to provide creativity? Or do we need another definition? What is creativity? The background of my question is that there are already existing systems for synthesis planning. You know, I'm a chemist, yeah, and there are programs now available for synthesis planning. these programs use, let's say, a big variety of information about the chemical processes and propose a synthesis route. And they are even able to forecast the yield and so on. Yeah. So this is something which before we said this is the creativity of a chemist. Yeah, to plan a synthesis route and so on and so on. Nowadays this is done by artificial intelligence. So what is your opinion? Yeah, is it are we, let's say, standing at the start of such development, or is it already completed? What is your opinion?
It's a very, very good question, by the way. It's also a question which in the evolutionary computation community, where I'm usually visiting conference, a lot of effort is been taken. I remember the human competitive results. There's always a competition at the Gecko conference, for example, about human competitive results, which goes towards this direction, where the idea is, can machines produce results which are human competitive in that sense that it would need human creativity to obtain such results. Often there are really fascinating results to listen to artificially generated music, which has been learned by a lot of music by a certain composer, which then sounds like it could have been composed by this certain composer, which is not yet creativity, I would say. It also comes to this A-to-I ratio. For example, what I would even say more towards creativity is that has been presented also in this evolutionary area. If you have, from mathematics, we know if you have periodic signals, there's the theory of Fourier transformation, where we can overlay many trigonometric functions with different amplitudes and different frequencies in order to approximate any periodical signal. And with genetic programming, it could be achieved without any theory about Fourier theory, just by giving data about periodic signal and basic grammar using addition, multiplication, trigonometrical functions, and so to learn the first amplitudes and frequencies, which then go towards Fourier transformation, or to have antenna designs which are able to be patented. Because if something is able to be patented, one of the requirements is that it needs creativity. And if you can artificially design something which can be patented, it can be considered as something creative. And those are very interesting questions, I think.
Thank you.
Great. I think that actually brings us to the last of our questions. So unless there's anyone in the audience that's keen to ask something and hasn't yet come forward, we may bring today's webinar to a close. I just wanted to thank you again for your time, Professor Affenzeller, and also to our chair, Peter Scharf. I found today's session very interesting. It's not a field of, it's not my background, history graduate as I am, these areas I'm learning more and more about the work that our members across the WTUN are doing, and I'm sure there'll be lots of people watching this back that are interested in finding out more. On that note, Professor Affenzeller, if anyone wanted to kind of follow up on the work that you're doing, I've shared the Heuristic Labs website in the chat, but if there's anyone that perhaps wants to continue this conversation with you, where's best to find you and the work that you're doing?
You mean about contact details also?
Yeah, or see the work that you do. You mentioned the Heuristic Lab. I guess that's a good starting point.
Yeah, that's a good starting point. Also, we have a homepage of our research group, which I can directly put into the chat.
That would be great. That would be wonderful.
With news, what from running projects and so on, contact details, of course, also, and publication lists and all. if you're interested, of course, I would be glad if you visit this information and get in touch with me as well.
Excellent.
You're highly welcome.
Thank you. So today's session was recorded, so it will be shared with all participants and also anyone that registered that wasn't able to attend live. So again, on behalf of the World Technology Universities Network, thank you very much for your time, and yeah, wish you a wonderful afternoon and a good evening to everyone whose day is starting to draw to a close. So thank you.
Thank you very much, Denise. Thanks for your attention also to all of you. Bye-bye.